Hi, everybody. It's Mark Thurman, and I'm here kicking off another Connected Things. This is Connected Things 2021, and I'm here with a very special guest. Asha Keddy, who's a corporate VP at Intel, is joining us and will be delivering a very interesting presentation, which I've just had the opportunity to preview. As a reminder for the audience, this is the second year that we've had to do a digital-only event because of COVID. The news is that we're pleased to announce that sometime after Labor Day, we plan on building a live mini Connected Things, and we will present more information to you a little bit later. It'll be up on our website. But right now, I want to welcome Asha Keddy. She's going to introduce herself and give a brief presentation. Following that, she and I will talk for a bit. So Asha, thank you again and welcome. And who are you?
Thank you again. Who am I? I feel like singing a song, but no, I'm
I have instruments, so you can sing.
But basically, I'm somebody who just wants to make this place a better place one day at a time. And the way I choose to do it right now is by being super passionate about connectivity, wireless areas, and I get to look at how we are connecting the world, including machines, not just humans, and also the role of how artificial intelligence and compute and all plays, and where we are going at in the future. And I work at Intel.
What's your title? What do you do at Intel, just for the audience's benefit?
My official title is Corporate Vice President for Next Generation Technologies and Standards. What I do for Intel is it means that I get to look at where we are, the strategy of where we're headed 3 to 5 years from now, both in the ecosystem, in the company, and in some of these inflection areas, and how and what our response should be. So in net, we look at incubating a lot of it's like an internal incubation team. And also we do a lot of the technology setting through things like standards. So the wireless standards team and all is a part of the team I manage.
No, that sounds great. We'll come back and we'll go back and forth after your presentation. But I'm going to sit back and enjoy. I know you're going to share your screen.
Thank you. So today I'm talking about 5G and the power of convergence, right? And we've heard a lot of this, and we've heard a lot of words around edge, cloud, and all of hybrid cloud. And what are we talking about? So before I dive into 5G, or even as we head towards 6G, let's take a step back. And 2G was really 2G was really around voice. 3G, we started the data revolution. Anybody remember there's an app for that? I actually still have one of those apps. It was 100 push-ups because I'm still not even at 10. But the reason I bring it up is in those days, the apps were not always connected. Or 3G was more, around cellular connectivity and not IP-based, right? So what it meant is that most of the times when there's an app for that, it was Wikipedia on the phone and all. It was very much through Wi-Fi centric areas and all of it. So with that in mind, 4G was designed for video calling. FaceTime Anywhere was one of the big ads. But technology is predictable. What human beings do with it is not. We just realized once we're connected anywhere, there were many entrepreneurs who then took it and made what we call the gig economy. Who knew that 4G would help enable the end of taxi unions, or a big stumble on those, right? Or change the way we do things, because now we're always connected. And in a lot of ways, we started trying to do with 4G things it was not designed for. For example, IoT, or Internet of Devices, battery things, because there what you're doing is taking something designed for video calling and IP networks and all, and starting to chop it or hack at it, versus actually designing for something that meets all these. So in comes 5G. Now, the same revolution that we had for humans with how our lives changed because of the phone is the same revolution that we want to see way beyond where humans are, like in terms of enterprises, in terms of cities and how they are run, because it's all about data and data everywhere. And with this, we need the flexibility. We need a lot of the customization, which, artificial intelligence comes in. And most of all, we need to process the data with a lot of the compute. And so it's really how we look at these converged things. In parallel, if you look at how the compute revolution evolved, it was very much around similar swings of like where you store the data. You used to have the mainframes where everything was central, and then you went to distributed with the PCs, but then you realized you wanted to store more and more data. Then you started creating the cloud, right? And then now it's back to being completely distributed again. So the point I'm trying to make is if you look at the convergence or connected compute, right? And I like how NGMN defines 5G as things that enable a fully connected, mobile, intelligent society. There's quite a handful there. But net, we're looking at connected compute at every level, all the way, whether it's in the cloud, it's in the network, or even if it's customized to me in my house versus my husband or somebody else. So that's kind of the backdrop we are working with. And if you look at the exponential growth, a lot of the use cases, if you go to Industry 4.0 or Mobile World Congress pre-pandemic, or even now in the virtual settings, you don't know which conference you are. I can go to Mobile World Conference and wonder if I'm in Industry 4.0 or vice versa. You go to an AI conference or look at AI and the use cases, they look to me the same as what we're doing in 5G or other areas. The reason for this is these are all force multipliers, especially the notion of having the compute right at the fingertips of like having the things, whether it's a comm service provider with mobile edges or whether it's cloud service providers with, working with enterprises or enterprises with compute storage on their premises. So these all become force multipliers that actually enable the same use cases. And the main point is not any of these technologies by themselves, but the pain points they solve for the enterprises or for the businesses and all of it. So all of this means the nature of data is also changing. The data is not as much broadcast, it's more uplink, right? It's more customized. It's more, if you look at it, right? If you can see very much from 1990 to 2025, look at the kinds of data and how the mix of it is completely changing. The use of client generated media, video surveillance, all of this is more uplink, which means the kind of times and how you design the downlink and the uplink and all we had to change in 5G, right? And a lot of the data between machines and all of it. So if you look at what the original systems were designed for, it's less than 20%. Or actually even much less than that by 2025, to where the systems today that we're designed for. And that just shows you how we have to think about this, not just from an air interface or type of device point of view, but also from the network point of view, which is where Intel has a pretty large play. Now, 5G has two aspects to it, the evolutionary aspect and the more revolutionary or the new use case aspect. The evolutionary aspect is very much around ensuring backwards compatibility. And we did a lot of this in what we call Release 15. It's really important to not break, so your phone continues to work when we move from 5G to 4G. A lot of it was focused on what we call enhanced mobile broadband. Essentially, we need acronyms for everything so nobody can understand what we're saying. And so EMBB is around, and it was designed really around capacity and data rates, more speeds and feeds, and more of the same. So up to 10 gigabits peak throughput and 1 gigabits in high mobility. And so a few things from there. We have continued evolution, massive MIMO, larger bandwidth, so you get like video sooner and faster. And concepts such as network slicing, where you can start looking at priorities or start to look at what is the priority of this kind of traffic versus maybe just a fun video and all. And also Release 15 started thinking about real-time support. But in general, it was really designed to enable the pillar around enhanced mobile broadband, which is an evolution of the same. The second pillar is much more around mission critical. And this is a brand new capability that was not there before. Over here, we're talking about some fundamental things that are game changers in providing flexibility and cutting the cord to wires, right? In a way, you could say even Wi-Fi and all cut the wires, but this is different because with this, you're getting the reliability of 99.999, right? Which is very, very high, like a wire. Um, and you're getting data rates. You can have bandwidths of like 1 gigahertz, so that means like 10 gig data, and much more than very high peak rates or even more. You have much more emphasis on uplink, and the latency is all the way down to 1 millisecond. You have other things enabled in these mission critical areas like time synchronization and TSN. What this means is then you can start guaranteeing quality of service in area. So think about this as extremely fast but reliable. Somebody told me once Wi-Fi is for humans and 5G is for robots. And you need this kind of precision when you start thinking about robotics or safety or other things in addition to the LiDARs and the radars and all of it. So that's a really important aspect. A third aspect is around massive machine time communications. And this one is much more around designing for 10 years of battery life, very low data rates, things that you would do where you'd have millions of sensors deployed in a city that are like giving data like power usage or the water usage in your house and things like that. So as we look at Release 16 is where we did a fundamental change also in making it easy to have private networks or standalone networks. So for example, an enterprise can now have a network through Spectrum, whether it's locally licensed Spectrum, which is a new form of Spectrum licensing, or shared Spectrum like CBRS, where they can choose to deploy their own network without going through a comm service provider. They could, of course, choose to do it with a comm service provider or even with a cloud service provider. So it just opens it up where you have more Wi-Fi like features, but with the reliability of 5G. And as we continue this, we're adding more features, including massive machine type communications, earth to satellite kind of communications, more precision around what you would need in an enterprise, like an operation network, like location. It's 3 meters now, but it'll get more towards even 3 inches as we go on through the releases, which is really important. So you know the locations of things on factory floors or campuses and all of it. And also the concept of different kinds of devices. Not all devices need to be as complex as the phone. So then we'll have things around reduced capability devices, like whether it's a watch or whether it's an AGV and all of it. And so all of these will just continue to play on each other and expand. Now let me pivot a little bit to networks, and which is the bulk of where even what Intel is really focused on. All of these things that I talked about require the data to be transported from the source to where it's processed to where it's consumed, right? For example, the source may be sensors, or the source or the destination may be an AGV in a factory, right? In all of this, the network design has to handle the amount of data, and it has to be flexible. There's various different use cases. Um, for those of you who remember, or if you don't, just humor me. About 20 years ago, and all, it would be like operators would say, 6 months down the road, push to talk, coming in 6 months. Now we can release services like that in minutes. And so when we look at how the network is, it's important for the networks to be evolving, to be virtualized. Back when it was designed, we used to have precision equipment, or you have to climb a tower, tilt the antenna, do all of that kind of work. Now, it's much easier to essentially have Lego blocks, if you will, or you democratize the compute where you have more flexibility because it's flexible programming. So we've moved from precision or fixed function to flexible functions. And this virtualization movement started on the core networks. And today, in many areas, about 60% of the core networks are already virtualized. And this virtualization movement is continuing to go towards the radio access network, which is what will enable a lot of the use cases we discussed. The use cases in the different geographies, like in India, in China, in different parts of India, even and China and the US, are fundamentally different, whether you're in a city or rural area, depending on the needs and all of this. And so we call this cloudification at Intel, and it's intelligence where it's needed, along with the flexibility and customization. And it's a scalable architecture, like Lego blocks, which really enables developer forums. And we have a lot of developer forums and open source things where you have efforts where you can enable very different kind of applications. So that's essentially in a nutshell. And we play a lot of this in different parts of the network because we power the network through compute or through things in the base station or the network switches and the optical and all of it. So that's how we play. But more importantly, that's how the networks are getting transformed. And keep in mind, we're also merging different technologies like Wi-Fi in the data points because Wi-Fi has such a big footprint, and also optical and silicon photonics make this area very exciting. Where are we now? The rollouts began 2 years ago and mainly on release 15. We'll see release 16 soon. And they're primarily on smartphones. And some of the biggest growth has been in China, USA, and South Korea. We have, I think, about 400 million subscribers, which is mind boggling, and 260 million in China, I think. So it really accelerated there. We have some pretty interesting statistics in all of these. I will not go through them, but as Mark said, these slides are available. And so you can just look at the amount of choices, even in more established market that this is having, and the business impact, the economics, and all of this that we see. The business case for unlocking 5G is around 4.3 trillion, according to KPMG. This is a higher number than you see from mobile operators and all, because they're looking at the total business and impact of 5G as an enabler versus just the 5G itself. And I love this chart because it really goes into the industry value and it goes sector by sector, and it has some component of the timeline or the number of years, and it also has the percentage of the value to be unlocked. And what I would say is if you look at all of these, right, it just shows how this is a transition in progress. And you can see what you don't see is as much as like phones, right? Or even watches. What you see is how you have public sector, financial sectors, healthcare, industrial, and all of it. So it's a very different thought process as we go through all of this throughout the year. And it will become one of the key enablers for how companies will differentiate from each other or even maintain themselves. When we talk about artificial intelligence and networks, one of the biggest use cases is around self-configuring networks, or the ability to quickly look at where are the problems in the network to help solve it, or to use the data to make quick decisions without human intervention. I talked a little bit about this before around local spectrums and private 5G networks when I talked about the standard slide. That is going to be key. There's going to be many, many companies that will have public coverage, broadband, scalable services. The comm service providers will run the network, and it will have all kinds of augmentation, low spectrum, mid spectrum, and millimeter wave. So you have different kinds of benefits and use cases using all three. As importantly, you'll have building or campus wide networks, enterprise networks where you'll have a lot of 5G, including with Wi-Fi, because the Wi-Fi will be used for a lot of the for a lot of the data and the footprint. But as you know, our use of data doubles every year, and maybe even more so in enterprises. So the different types of data will be routed, whether it's through 5G or Wi-Fi, based on its latency, its quality of service requirement. And this private networks can be licensed spectrum, unlicensed spectrum, shared spectrum, locally licensed spectrum. So a whole bunch of exciting new models. And you always need to have things that are both on hybrid models where um, an enterprise can outsource to a service provider for things like for some kind of data, but keep maybe some of the operational data in house. So, net net, what you see with private networks is a lot of the concepts of what we conventionally call information networks or IT. The operational networks are how the enterprise is run, and the comms networks are the what used to be voice and data and all converge because it's all data. And that just to bring this to life, just to bring what you see over here is the kind and the variety of players. I talked briefly about information networks, operational networks, comm service provider, cloud. It's all data. So you see everybody making a play in this area because it is the future, is the transformation of the enterprises. And this pretty chart here talks about how this is from Omdia, and it talks about how the percentages go across the different sectors around 2025. And so this is a very exciting time to from this point of view. Um, And to sum it all up, before I start wrapping up, these, as I explained, have its precision use cases or customized use cases depending on the kind of private network it is. For example, in factories, one of the big needs is real-time motion control or augment. That's one big thing, right? It has to be precise. Another big thing in a factory is AR, VR, or augmented information. It doesn't necessarily have to be through a lens. It could be, or it could even be through like a tablet or something where you're going by inventory and you get the information based on your location and all what it is. It helps you find parts sooner. It helps you replace things sooner. It helps you debug. So you're getting information that would take longer. So it's assisting you, saving a lot of cost and downtime. Campus and venues, it's more around, again, more information than you would get otherwise. Immersive media, real time media, fun sports, competitions that you can enable on the fly, and all of it. Um, Mining, it's one of the hottest use case for robots and the dynamic scale and deployment. On this, we basically have construction and a lot of the places where you can use this is you can send robots in and other things with data. And so you not only save a lot of human lives, you actually are much more precise in how you do the operations and all of it. So mining is one of the core elements where it's very effective to help put a network that can help you augment several aspects of it, from safety to precision to getting the data to actually getting this done right. Construction is another area. And as we continue to emerge from the pandemic, hospitals, healthcare, how we do healthcare becomes more important. Well, I have gone to the doctor remotely during the pandemic, and a lot of it will become more common where I might have monitoring devices or things that actually help with this kind of data. And then we might have even more over time, more um, uh, precise things or more complex things like x-rays or computer vision or quality of service or all these kind of things where I can just look at the charts and look at how do we look at all of these things much quicker. So that's it in a nutshell. Um, um, and quickly, if I go to beyond 5G, I look at how do we take this focus all the way to not just we started with compute and connected compute, but it's basically connected communication compute with data and looking at how we scale this compute from the cloud to the edge to the network edge and to the devices all the way, right? How do we use data at the center of the transformation? So everything is designed as a data. Even compute and all becomes like how we process the data. And what's really exciting about this is when you start looking at latencies of zero point 0.1 millisecond, we start looking at things like RDMA access, which means direct memory access. And it really means that the entire network of the world becomes one computer, and that becomes fast over time. So it's a very exciting way to think about it. And as we do all of this, there are several efforts around the world that focus on it, both internationally or things that we have enabled with leaders like in Japan, NextG alliances through HIS in the US, Hexahexes in Europe, and National Science Foundation is also taking a really good leadership role here. And um, as we design the future, it's really important that we look at this from sustainability in mind, inclusion, like making sure that we have cost solutions for there's still like over a billion people not connected, or there's still people who have different needs, like and different priorities, like aging population and all, or young folks in schools who have different needs, health, safety. How do we look at making this better, not just for us, but also for the planet, the environment, and all by using all of those data is a huge focus on it. For example, in the ION or the innovative optical wireless network, there's an emphasis to make it mostly renewable or 1,000th of the power that it consumes today. Power consumption is the biggest operating cost and energy drain in a network. So all of these are to say that we're designing these with sustainability, digital inclusion of different kinds of requirements and different segments of population, health and safety in mind. Thank you.
Asha, thank you. That was a great keynote address. I was jotting down, I have little sticky notes all over my screen now. That was a great presentation, and I think it was very, very, very beneficial for our audience. So, I want to just jump in with a few questions. So, and you don't have to bring these back up as I refer to them at all, but you talked about the various jumping in the middle, the various frequencies and along the way in the spectrum. So my question is really, if I'm in the CTO's office or CIO's office at an enterprise, do I need to keep this in mind? Do I need to start thinking about spectrum allocation, or if I'm in the US, if I'm using CBRS for private 5G, do I need to think about that? If so, why or why not? And what are the things I need to kind of keep in mind if I'm in that role?
Good. Thank you. I think it's super important for the CIOs and CTOs to think about it and keep in mind these information systems become the same system over time. Today, a lot of the IT systems are already outsourced, right? Like whether it's Microsoft Teams or Google or something else. Back in the day, enterprises used to have their own network, which was customizable but more expensive. And now we have a pretty feature-rich things that is like outsourced, right? Now, if you think about the future, the operational networks are key, and also the information networks. Enterprises will have to be thinking about what are their needs, including privacy, security, and all of this. So they have to start thinking about how they're going to get the spectrum, whether it's licensed or unlicensed, or shared spectrum or otherwise. They're going to have to think about who do they partner with. Are they going to get it from a comm service provider or like a cloud, a combination like, working with Microsoft Azure on their network? And how do they want to integrate it? And what do they want to keep private? What do they want to keep on-premise or secure? Because for a lot of these use cases to work, you can't get either for privacy reasons or latency reasons, or security reasons, you can't get it off the premise. And if they do not think about these, right, there are others who would. So you're almost missing out on the inflection where these capabilities add a lot of flexibility to your operating things. So it's like a different way to see it is, what would you do without a smartphone, right? Like if you think and others start having the smartphone, you just lose out on all these experiences, and enterprises have to be super competitive, right, to survive. Even like even the minute I live in Portland, it's a land of microbreweries. And when we used to have games where you could crowd, and maybe we'll have it this year, the time you even have to realize the barrel is empty and change it is opportunity lost, right?
That's right.
And time you set up a factory and tear it down, or the time in the interface it takes you to locate information, where it doesn't even have to be parts. It can be digital information. I work at Intel. There may be a lot of things on the Intel network that I need to do my job that's electronic. All of this is cost and efficiency.
So what you're saying is it's important for CTO, CIO office or enterprise practitioners to be aware of the standards and what their use cases might be. So kind of along those lines, the role of standards in 5G and IoT. And again, this is an IoT conference talking about 5G. So from that perspective, again, what are the roles of the various standards? Which ones should I pay attention to? Which ones maybe not so much, in your opinion?
I think it's a good question because I would pay more attention to the capabilities versus the standards itself, right, as an enterprise, because and it's kind of that's the problem. It's kind of like a big platter of many different things. So I talked about enhanced mobile broadband and
Right.
then enterprise-oriented stuff and smart city stuff. So I would look at the capabilities that impact that particular area and go at it from that way versus the standards itself. And remember, there's a force multiplier. So you have 5G, and so I start with the use cases of the pain points, and then of course these get implemented through things in 3GPP, which is the cellular standards, IEEE and Wi-Fi lines for Wi-Fi or unlicensed areas. But as importantly, there's a huge open source movement, whether it's and different open source kind of areas, whether it's run by cloud service providers or Open Network Foundation or openness and other areas. So there's a lot of open source and other software efforts that become as important.
Well, I think that's fair. And you kind of touched on another question I written down, and I do keep sticky notes, so I was taking notes, believe it or not. Licensed versus unlicensed spectrum in the realm of IoT. What's your personal view on that?
You need both. You need all the spectrum you can get over time. I mean, Wi-Fi is not going anywhere, and yes, you can use the unlicensed even on 5G. So the way I look at it is for things that are not mission critical, right? Unlicensed is plenty good, right? We have a lot of it. It helps us. So we also so and it has a big footprint, and license becomes more important when you have to get a particular quality of service or some efficiency and all of that. So it's all about the cost mix, and so I view both as super important as we go figure this out.
No, I think that makes sense. So you talked about network virtualization, and again, the question really is from the perspective of a office of the CTO at a enterprise. What do they need to know? What are the enterprise benefits of that?
Good question. Choice
I like that.
and flexibility. So if I had to sum it up, I'd say choice and flexibility. The CTO and CIO really need to work together, right? Because the CIO almost has the budget, if you will, to transform it, but the CTO knows more focused on how the trends. And some enterprises even combine the two functions now, right? You have
Right.
CTIO offices even, right? But and with a bit of strategy in there. But if you actually look at it, it's really around flexibility and cost and efficiency, the way I look at it. And the flexibility is two ways: flexibility to do more innovative things, or flexibility to optimize what you're doing.
No, I think that makes sense. Um, sort of along those lines, we'll kind of go to sort of Intel's role. You've touched on it a bit. So if I understood it correctly, and you may want to expand on this, Intel's role in 5G is really from a standards setting or participating in the standards organizations, how would how would the output of your efforts be realized by an enterprise? Maybe that's the best way to phrase it.
Sounds good. We talked about virtualization, and I view virtualization in a way of democratization, right? So to me, it's a different way to say democratization. And so a lot of our efforts in the standard setting and the open source community and all is around um, more Lego blocks. Like I like the Lego, and so almost opening up the different parts of the network, right? So something used to be a big black box, and then it's now smaller, and now it's core, and now you can mix and match parts, or you can have the supply choice and diversity. So the way I look at virtualization is it makes it where you can get off the shelf components and start building it, right? So it's not as expensive or as precise. And then over time you get the performance starts catching up. So I'd look at Intel's efforts and push on this solidly around the democratization of the network. And the more you democratize the network, the more flexible also it is in terms of what it can do.
No, I think that makes sense. So I guess this leads me to ask whether or not Intel's been doing any trials or proofs of concept (POCs), which verticals, and what have you guys learned from that?
We have done several hundred trials around the world, both on the network side, on the air interface side, combinations, and all of it. And 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 we've done it in many sectors, whether it's right from agriculture to sports, like sports viewership, to media intense things. We even had the Olympics in Korea, powered by Intel was the 5G sponsor, so we had like a lot of the world's first 5G operating network with Intel partners, telcos, and comm service providers. So we've done it in pretty much all the verticals that we talked about earlier in the presentation. Healthcare got stalled a little bit because the pandemic refocused it. But what we have learned from it is same thing I started with. Human technology is predictable. How humans use it with it is not. And I find that many businesses solve it in ways I haven't imagined. It's important for us to be the enabler, and some of the mistakes I think we made in 5G were around in the early days, starting to design things for a different industry versus looking at working with them and having them drive what we design. I think we especially did this in cars, right? The connected car had a little bit of a hiccup, and some of the IoT things was not fast enough, which is why I had more proprietary solutions. So to bring it back, I think it's important for the industries to drive it, their pain points. And like one of my favorite use cases is these ships. We did it with Sonara that came in from in the Baltic area. And it would take a long time to put optical fibers to get them Wi-Fi because they would stay overnight.
Right.
And then you set that in a few minutes. Or with Fox Sports, they could just
Sorry.
okay, and 8K, like 4K videos to people's houses versus doing fiber rolls, right? And these just are such powerful use cases. And it means like maybe your somebody's children's playground, they can have 4K video, watch it from their house. We now want to virtual access to everything, even though we're going back in person. So when they start solving the pain points, it's much more powerful and much more focused, and versus the 5G heads talking at city commissioners and other folks.
That's right. So you kind of talked a little bit about pandemic essentially, or what we've kind of learned. But let's specifically, because we're at the tail end. We're recording this in mid-June. We're at the tail end, hopefully, of this terrible pandemic that's impacted everybody worldwide. What have we learned about data networks? I mean, I can guess that Zoom usage went up, but what else have we learned? How resilient do you think these networks are? And how does 5G play into that, if at all?
So a few comments there. Okay. First of all, I think we learned the data networks are fairly resilient, right? The more I have to give a shout out to the comm service providers because they did a phenomenal job in meeting the demand. And it also, maybe we filled pockets with Wi-Fi and other broadband usage. Having said that, we also saw we need to do a lot more. There are so many children who do not have the same access that their neighbors have, or the people sharing equipment. We have a huge silicon shortage, right? And so I think it just accelerated a lot of these transformations, if you will. And back to resiliency, I think resiliency is like an onion, many layers, right? And so I think we have to address it one layer at a time. You've seen some of the negative things like cyber attacks in areas. You've seen we depend on Taiwan a lot, and Taiwan is undergoing a health setback right now. And so we're finding that we're having to build resiliency with the human factor involved and in layers that we never thought before. Having said that, um, I think the US is in a very fortunate position right now to be talking about the tail end of a pandemic. Most of the world is not. So, for example, my family in India or others, they laugh at me when I talk about when you're going to visit. Like they're saying, like they're in lockdown, right?
Yeah.
UK extended it, and so when you start thinking about internationally, it's still going to be much more around virtual settings, and we'll still need to design. For example, back to your question you had on the enterprises, right? In factories, we have to design, for example, how people from one country can log in and debug into another country because
Right.
international travel is still going to be pretty messy for a few years till we're all vaccinated. So even something simple like remote login and remote debugging so that I can control some factory equipment or help people there becomes important. So long story short, I think resiliency is like an onion, except the onion is even more bigger and complicated. And we're going to deal with people in the pandemic in countries and locations in different phases for the next few years.
So and I know we're going a little bit long, so I ask the audience to bear with us. Um, this is sort of unrelated to 5G and IoT, but so you're in leadership, and I believe have a team of people that you work with, and they are probably geographically dispersed. From and also you have to deal with clients and partners and management and everything else. How have you managed during this year and a half of new way of working with respect to the pandemic? Just it has nothing to do with IoT or 5G, but just sort of this new way of doing work. And do you see coming back to what it was, 2 years ago? Going into an office every day, presumably, or getting on airplanes, or do you find that you're going to, maybe leverage Zoom or Teams more often?
I think uh, I think hybrid is the new buzzword, right? And flexibility is the new, thing that is out coming out of this. So I think it changes. Like the grocery store, workers have to be at the grocery store. So some areas are more rigid, but some areas like my area or even Intel, right, is moving many of the things, software and all, into a hybrid mode where there are expectations that you have to be able to be on site with some notice, right?
Right.
And offsite, or particular times, right? So it's both. And then there are some environments that are completely virtual. Putting all of that aside, I think what it means is we have become much more comfortable, not fully because we do need the human interaction, but Mark, you and I can do this. And so maybe we would meet once a year if I had to do something, and the rest be hybrid. So you maintain that balance, but you can also get other things done. My dog is probably the happiest in this house, right? And but jokes aside, I think it becomes important for us to pace ourselves. Emotional health, mental health, wellness, they become much more important because we can like do three things. I can do something, right? So how do we pace ourselves? How do we start grappling with this? And even schools, many schools are declaring no snow days, or snow days become online days, right? And so it means that my house or a teacher's room has to have a replicated environment, right? And so that means like it has all kinds of implications. People are moving into bigger houses from apartments or all of those kind of things, or choosing where to live separately, differently, right? So I think it has it's human behavior is not predictable, as I always say. I think we'll have different way customizations, but net we have also learned how much we can do virtually.
Yeah, I think it's interesting. It's a brave new world. I haven't been on
Hmm.
an airplane in 16 months, and I used to travel 3 times a month. So, all over the world. But I'm going to close with two sort of related questions. Thank you for that. I'm always curious of the impact of COVID and what we've learned from it, and how we move forward from it. So that was the prior question. But so a related set of questions around monetization, because it's all about the money. At the end of the day, that's how we all pay our bills. So both monetizing the edge, I get that question a lot from mobile operators and also the cable folks, the MNOs and MSOs are looking for some guidance on how to monetize their edge. And then the related point would be just a quick comment or two from you on IoT data monetization. Is that a thing, or is that a thing to be avoided? So jump in on either of those and then we'll wrap up.
Um, can you just repeat the last part again?
Okay, so
Data monitor. Go
the
ahead.
first one is monetizing the edge. Any guidance for telcos and cable operators? I'll stop there.
Okay. I always trip on monetization for monetization's sake, right? So I think the key is to remove the pain points and help the data be actionable and to solve the enterprise pain points, right? Right now, especially telcos, they are in this challenging environment where they're starting to look at how they can use data, like media acquisitions, big ones, right? They're changing their identities. It's
Right.
because the traditional way of just looking at how much to charge on the data rate has worked very poorly for them. So now they're looking at content, right? And but even content is now changing towards customizable data. So I would think that they should. So if they can just work to look at solving the pain points of the content or customizable and actionable data, I think that would be a good one for comm service providers. Cloud service providers already know how to do this well. And with all the data being there, they have to figure out, are they going to partner? Are they going to be a frenemy? Co-opetition is a commonly used word. They have to figure out what role they want to play.
So overall, with respect to IoT data, is
Hmm.
a method or means or uh, any thought leadership that you can provide on just monetizing IoT data? But and let me be very specific what I mean, just so that it doesn't, excuse me, lead you in the wrong direction. So machine data, is that monetizable? I don't know if that's a word, but can one monetize machine and sensor data? And if so, how, or should we not even worry about that?
Um, Only 2% of the data we generate is processed. And I think just the New York Times or Wall Street Journal edition has more data today than people 2000 years ago had in their entire time frame. So the short answer is, who is that data useful to? Right? So if it is, so if the data is useful, for example, IoT data from a billboard, if it can be like how many people pass by, right? That billboard, that's monetizable. If it looks like what are the traffic looks and all of it, right? Or any place where you can do targeted advertising. So when you talk about money, you talk about consumers because consumers consume or people with money. So any data that is helpful for me to target how I spend my money, use my money, is monetizable. Now, and even within an enterprise, even if I don't sell my data, I can still use the data to make better economic purchasing decisions. And then in a more public setting, right, I think that IoT data in a public setting is very monetizable, right? How much electricity, where do you go, how do I encourage you? The city uses too much electricity, or the city likes, I don't know, uh, vegan bars a lot, right? So how do you like advertise it so that you have it more targeted, right? The city likes beef a lot. I'm just making it up, but
No, but it's good.
right? And so anything that helps you target it is monetizable. So short answer is yes. Even though in many either to save money or to target it, right?
Well, I think makes very good sense. Um, I don't know if you have any final comment that you want to make, but I have to tell you that I've been moderating this event for a number of years. You just gave a very complete and in my mind, informative overview of the issues around IoT and 5G. Um, Again, we will make the slide deck available to folks who want to contact us and get it. We have a PDF of it that we'll provide. And we're hopeful that, Asha, we can convince you to participate with us again in upcoming, hopefully in-person events that you can get on an airplane and fly to, because I think you'd enjoy our audience as well. But I really want to thank you very much for your time and for the time that your team put in to help us arrange this. And on behalf of the entire Connected Things team, we're really grateful for your participation today.
Thank you so much. Thank you again. And I love the idea of back to that in-person thing, because the thing I miss most about it is the experience. I mean, this is a wonderful experience, but like in person means I see the person on the street, I go to a local food stall and eat that. I have the interaction. I might know a person or two from the audience and you connect there, right? So all of those experiences, I think, are so much more richer with the in-person, right? And so I do miss that a lot. So I'm looking forward to starting to bring it back in moderation.
Well, that's perfect.
Thank you.
And I just a very quick closing comment to what you just said. In our conferences, our audience has a great way of participating with our keynote speakers. So we do invite you back, and I think you'd enjoy the engagement and the networking. 80% of the magic that happens, aside from the great content, is really the one-on-one,
Networking.
the small group interactions. So I think you would.
Yes. I guess it's just the impromptu side conversations and things that click and you see it immediately in people's faces and the scaling of that. So yes, thank you so much. And the food. The food is a big part of travel to me, right? All the experiences, like even like the culture wars on pizza even.
And we occasionally will serve beer and wine. So we even
Even better.
thank you again. I really
Thank you again.